Hi makers, I'm Anna Kazunas France, digital fabrication editor at Maker Media, and I'm here with Stephanie Mueller and Tobias Moore. They're over at the Human Computer Interaction Lab at the Hasso-Plattner Institute, and they're going to walk us through a live demonstration of their fabricator software and assemble a prototype for us. So Stephanie and Tomas, can you tell us a little bit about fabrication?
Yeah, thanks, Anna. So fabrication is basically a piece of software that allows you to save 3D printing time while you're prototyping an object. So the main idea is basically to save the 3D printing time by substituting some parts of the model with Lego bricks. So the idea is you only use the high resolution of the 3D printer where you actually need it, and the rest you can just, replace with the bricks you already have on your shelf, takes you no printing time, and is super fast.
Fantastic. So tell us a little bit about, why you started this project, how it came to be, what need that you saw for this.
Yeah, so in our lab we do a lot of prototyping, mainly for interactive devices. So we are a human-computer interaction lab, and we create these new input devices, and we often need casings, or we need some, some mounts and other functional objects. And there we actually noticed that 3D printing, is very, very slow, and you don't often need to actually 3D print everything. So maybe I can just show some example objects.
Great.
So this is something we love in human-computer interaction. It's a head-mounted display. And actually, when you start to create this here, you don't really need to print everything, because at the beginning, you might only need the lenses to be in the correct position. So you need to have the lens mounts at the right location. So what you can basically do with our software is to say, okay, I just mark up the lens mounts as 3D printed. I hope you can see this here. And
move it over to the left a little bit.
Yep.
Yeah, that's perfect.
Awesome.
Thanks, Tobias. Great, perfect.
Yeah, you only have two hands. So here you can see we actually only printed the lens mounts, and this takes you only around an hour. And the Lego sits on your shelf, so you just assemble it. But if you would print it in its entirety, it would take you around 14 hours. So it's a factor of 14 that you can save here. And once you start, basically, once you have this basic version, you can always go back and you say, okay, maybe I need more comfortable pieces for my head here, so I don't have the Lego knobs on my head. And then, you just print a small piece and you replace it, basically. And, that takes you maybe another hour, but you can basically, have this modular approach of exchanging parts.
So it helps speed up iterations of prototypes, right?
Yes, that's basically the main point. If you print this as one piece, it takes you 14 hours. That's more than a work day. So you basically have to print it overnight. And then, the next day you come to your office, you make a small change if you are a designer. That might only take you half an hour, but then again, you need to wait another 14 hours. So again, you wait overnight and so on. So basically the design work that might have taken you only maybe a few hours basically stretches out over the course of an entire week. And that's basically the idea of the project, to have multiple design iterations in a day rather than, stretching them out.
Fantastic. Sounds like a real time saver. You could get the prototype done in a day, as you mentioned. So what was the project that kind of started this for you? Were you looking at simply speeding things up, or did you have a project you were working on that had to get sped up quickly?
So basically what I do in my PhD work, and you may have seen the other projects that I did in the past, laser origami and constructible, they are all about, helping you to speed up prototyping, because, our rapid prototyping tools, they are not really rapid, and I think everybody who used this 3D printer knows about that. So coming from this background of actually using it for my daily work, for the daily prototyping, I know that there's a lot of stuff you can improve on. And that's basically where we started this project. And Lego is already a great prototyping, how do you say, toolkit.
Right.
But you know, it basically lacks the resolution for doing more advanced stuff, for doing really functional mechanical parts. There you really need this 3D printing, and you cannot build everything from Lego. So we try to combine the best from both worlds, and I think it's really exciting to see this come together here as a simple prototype.
That's great. So that's a heads-up display for an iPhone, or oh,
We
that's
should,
okay. We lost your sound for about 5 minutes or so when you started
very
explaining.
sorry.
No, that's okay. We've got time to go over it again. Sorry about that, audience. We lost their sound. So
Okay.
no
So
problem.
that's probably the external mic.
Yeah, it seems to be
I thought it was
working,
me.
so we have.
That's okay. So we'll start over.
Okay.
So you were talking about the heads-up display. I had asked you, does it work with an iPhone? And then
Okay.
we lost your sound. So
Okay, very sorry.
let's do that again. Sorry,
Okay.
guys.
So you basically, you attach the phone and you have the lenses in there, and then you can download every app from the App Store, and you can basically test right away if these apps are working. But of course, Lego is only, for us, it's a way to prototype and, to iteratively work towards your design goal quickly. So of
Exactly.
course, these model at the end will eventually, will be 3D printed at the end.
Okay.
Rather than printing it 6 times or 7 times completely, you only print it once completely at the end. And for the iterations in between, you only print the parts you really need to rework, to redesign. And that's the main thing.
So you mentioned an app from the App Store. What were you using for this kind of prototype?
So I think I just downloaded the GoTo. I don't recall the exact name. It was called GoToFof or something. If you go to the web page, there's a laser cut head mount display also, and they provide the app. But I don't recall the exact name. I can share it later if you.
Great. Well, we'll post that link a little later on. So you were probably talking about, adjusting the lenses and the headpiece.
Yeah.
So tell me a little bit about that process, how you went through that with faBrickation.
So yes, so basically you start by, you load the 3D model, and then you just need to click one button and it will generate a Lego version from that model. So a complete Legofication. And then, yeah, that's the term we use really.
I love that, Legofication.
And then you basically, in software, you just use a brush and you select the parts that you want 3D printed. And at the end, you only click an export button and you get the STL files. So, sorry?
Oh, go ahead. Keep going.
So I can show you a demo of our tool with a different object. So
we would love to see that.
Great. Did you get the part with the soap bar dispenser, or the audio was already gone, right?
The audio was gone, so we'll let you do that again.
So this is basically a soap bar dispenser. You put a soap inside, and you have some razor blades in the bottom, and you can rub it back and forth, and then get some soap flakes from the bottom. So let me just show it to you in our software. So I hope you can all see that. That's the top bar, the top part of the soap dispenser. And I just loaded this 3D model, and now I can click Legofy. And now you basically have a Lego representation, but you can see it's only the 1x1 Legos, so the small ones. But once you hit the layout button, you basically,
so Stephanie, are you showing your screen right now?
Yes, I'm showing my screen right now.
Okay, I can't see it. So let's see. Is it showing up as a screen to you?
Yes.
Let's see. Okay, now I see it. Great, keep going, sorry.
Okay, should I restart or just continue?
Nope, we hear that you can see it, so everyone can see it, so that's great. Keep going.
Okay, great. So now you have a complete Lego representation, and what you can do now is basically you can use the brushes here on the right side, and you can, for instance, use the high-res brush to define 3D printed regions. So you can say, for instance, for this soap holder here, the slat is very important where you move it back and forth. So you just mark this part, and you go around the model and say, okay, this part should be 3D printed, and this as well. And now you basically have the bottom part already defined. And what you can do now, you can just click the export button here. And this will export you the bottom piece as an STL file. So let me just show you this in my... So we currently export just here to exports. And then you get a brick file here for the brick you just defined.
Oh, very cool.
And if you open that in MeshLab, you can see it has all these connecting knobs that you can basically use to. So here you go. So this is basically the bottom brick you can now send to your 3D printer. I hope you can see that.
I can.
And you have all the knobs here to actually put your Legos on top. So it's very easy to continue prototyping from here. And what we also provide is a set of very basic instructions. So once you have it 3D printed, you can basically say start instructions. And now you get highlighted in blue, and you can step through, and it will show you which kind of bricks you need to actually assemble the model.
Oh, wow.
Yep, and then you're basically done. And so for this model, you know, if you completely 3D print it, it takes 6 hours with the bottom part. And if you only use, you know, the high resolution parts that you really need, it only takes you 2 hours. So you have a big time saving here, and assembling this takes just, I think, around 4 minutes or so.
Very cool. So how do you determine exactly how much of a part needs to be kind of specialized? What is your thinking through that?
Yeah, so basically, faBrickation is for functional parts that need the high resolution of the 3D printer. So for the soap dispenser, it's basically this bottom part here where the razor blades sit. So they need to be connected here in the sides. So this part is 3D printed, and the rest is Lego. And also the slit is basically a functional part. So here this really needs to fit precisely.
Okay,
so
great.
We say for faBrickation it's really only for functional and mechanical objects. So if you have a decorative object, you know, you probably want to have the entire shape exactly as defined in the 3D model. But there you also don't need that many, you know, iterations on how to build stuff.
Right. I can see that.
Maybe to have like the maker here is actually the biggest example we made so far. So thanks for this suggestion.
Oh, he looks great.
So
it's huge.
Yeah, it's huge, and it would take 60 hours, right, to print it. That's a long time. So what we basically did, we loaded it into faBrickation, and we only printed the joints. So here you see the head joint, and I think the arms. Can you take it apart? Right. And basically the 2 joints for the arms. And if you only print those, it takes 6 hours compared to the 60 hours. That's quite an improvement, and you know that basically also used up all of our Lego. So
definitely. So we can see the joint in the arm there.
Yes, exactly.
So did you get this right on the first try, or did you have to do multiple prototypes and iterations of the joints?
First try.
So Tobias built it. Maybe you can say a bit more about this.
So this is like really just using it at the first try. This means the actual model consists out of multiple models, which some user at Thingiverse loaded up, and you can actually move the whole thing with servos and an Arduino. And the only thing I had to do, if you want to show the video, is to load the models into the faBrickation. Lego ties the whole model, and selecting actually which parts I want to have as a functional part. In this case, we have like the 6 joints, like you see and the two splines which are originally. And Stephanie shows now the screencast of, this is the upper part of the Makey, how we call him. Yeah.
Yes.
Yeah. This is actually like this part, which is built. Oh yeah.
So yeah, here you see again we use a brush to define which parts should be 3D printed, and at the end we basically say layout, and it will merge all the bricks together. And now you can see that actually the head part is one big piece. And here you can see that we can also switch back and forth between Lego and high resolution. So we can say, you know, maybe you made a wrong decision and you want to have it Lego fight back, then you can just, you know, convert between high resolution and low resolution back and forth.
Great. And is this in real time, this video?
Yeah, that's real time.
Oh, great. That's fast.
That's the goal.
That's really fast. I expected maybe rendering time, or maybe this was sped up a little bit, but real time, that's great.
Yeah.
So I believe you mentioned that you had cut up the original kind of Makey STL into pieces and then put the joints in. That was done in a modeling program?
No. No, this completely, this huge Makey, this like, we don't talk about the small figures you find, which on every maker fair you get.
Yes.
This is from a different user who used the whole model, scaled it up, and built an actual robot out of it.
Oh,
so
okay,
we
right.
downloaded the full model. It's called Animated Make Robot.
Oh, I saw that. Okay,
yeah.
Great. Yeah, I'll post a link to that for everyone.
So yeah, that was also very important for us to have our software, you know, it's very generic. You can basically download, you know, if you have a clean Thingiverse model, you download it, you can load it in, and immediately you can Legofy it and make these 3D printed parts. So that's basically very important for us, that it works for every model you want to make, right?
Great. Yeah, that's great. I didn't realize that was the... You had mentioned it earlier, the Arduino one, but I didn't realize it was the separate model with the jointed Makey. That's fantastic.
And, you know, we are always happy to have a bigger collection of example objects. So if people out there want to have something made with faBrickation, you know, we are currently re-engineering the software to make it, you know, even better before we upload it. But if you have cool ideas on which objects should be made, please send us an email, and we are happy to try it out.
That sounds great. So tell me a little bit more about when this is going to be available. And I know you're presenting it as a paper coming up at a conference. Tell us a little bit about that.
Yeah, so basically faBrickation is a full paper at the CHI conference. That's the biggest conference in human-computer interaction, and it will be held in May in Toronto. So there will be 3,000 attendees.
Oh.
And we will be there, and we will demo it 4 days live. So we better make sure that the software is really robust at that point.
Well, it looks great already. You know, it's fast, and it seems to be working. So that's fantastic. You're well on your way. And you had mentioned that after the conference, after you get the software completely the way you want it, that you're going to open source it and post it on GitHub. Is that still the plan?
Yeah, exactly. So that's very important for me to have like all the software, you know, available at the end, and that people can actually use it. And I mean, it's super great that, you know, it's so easy today to share it and to make it available to people, and that they can further develop and put in their own ideas. So end of May is definitely our deadline for uploading the stuff.
Fantastic. I'm really looking forward to playing with that myself.
Yep. It's also, we decided to put the full component, as you maybe saw at Stephanie's demo, as in browser app. So actually all our projects before were like you had to download them from GitHub, had to compile them. They don't work on your operating system. So this is actually like all works in your browser. It's completely operating system independent, and you don't even have to install it. So we even think about like hosting the basic version so that people just can go to an URL and just Legofy their own stuff.
That's really great. That helps a lot to make it more accessible to a wider audience.
Yeah,
Fantastic.
exactly.
I'm just looking to see if we have any questions. I don't see any. If anyone has any questions, please post it either to the YouTube page or to the Google event page, and we'll do our best to answer them. I don't see any right now. I'll give it a couple more minutes and we'll chat just a little bit more, but I don't see any right now, so keep an eye on that. Well, that sounds great. I'm really looking forward to getting to play with this myself, as I mentioned, and we'll have to post some type of page where people can share, all the fantastic things that they fabricate and Legofy. So that sounds really great. Is there anything else that you want to mention about this project or any other projects that you're working on?
At the moment, and as Stephanie already told, we improved the software, which is mostly my part, and we try to getting it bigger, in the sense that this model is already really wonderful because it has a speed up time of 10 times faster than the original print. And we figured out the bigger you go in functional systems and the more Lego you can substitute of the original model, the more speed up time you get. So our weakest spot at the moment is that at Thingiverse, lots of models user load up are just for their really small sized 3D printers, which is 6x6 inch or 8x8 inch. And this means this whole robot wouldn't even fit on a build plate. Yes. And that's why we looking for people who contact us, telling us, would this be a good model? Would this be a good scenario to do this? On this fact, also to mention, because at the moment we just see Lego, we also have other block or brick systems. For example, we also support the Japanese nano blocks, they are called. These are smaller, you mostly get them as souvenirs or a lot in Japan. We have the Lunematic construction blocks, I think they're called. These are they have this size per block, so you can build actually couches out of them. Then we have the Duplo and the whole Lego universe. So Lego has not just the normal Lego bricks, has also the plates, the Duplo, and this is actually it. And we're also providing in basic API to define your own brick system. So if you have a brick system we not mentioned yet, or just tell it us. Maybe we can already include it when we ship.
Wow, that's fantastic. I had no idea that you were including that many brick systems. What's involved in doing that? How do you modify the software? Is it just kind of the dimensions of the bricks and then the spacing of the parts that snap together?
Yeah, so far we basically provide a settings file, and you can enter which kind of bricks you have. So you can say, okay, I have 2x2 Legos and 4x2 Legos and 6x2 Legos and so on. So you can define your sizes. You can also say if you have plates or only the regular Legos. So, and as a little gimmick, we also said you can define how many Legos you have from one type. So the layouter also knows when you run out of a certain type of Legos and then just, doesn't use it anymore. And it's basically the same for the nano bricks and the other ones. So you just define what you have, and the software then makes use of it, and the layouter knows, what you have at home.
Wow, you've been really busy. So how long did this take you to develop? You're obviously, in a school, in a program, and you're working on other projects. How long did it take you to make this software?
So, for our projects, we apply the same approach that we suggest here for, 3D printing stuff, that you iterate. So the first version was really a quick thing. So the software you see in the video took us 6 weeks.
Oh, wow.
As a people project, so that was really fast. But, then you always have some small problems that, you figure out on your way. So basically, since the last 4 or 5 months, Tobias is basically re-implementing and re-engineering and making it really stable and beautiful and, extendable for other people. And it should be really easy to extend. So it basically runs in the browser. It's written in CoffeeScript. So if you can do some JavaScript and CoffeeScript, you basically are able to, modify it on your way.
We already even have like 2 other student projects who already use it as a platform. So it grows faster than we even thought in the beginning. And yeah, I think it has at the moment already lots of features in error correcting and so on to make it really as easy for the user as it possible is, so that even in the end the kid can say, Dad, I want to have this model, and Dad just prints the functional parts of this model, and the kid can completely assemble the whole part with the printed Lego bricks that Dad printed for it.
That's great. So that's really more than just a kind of, Legofication system. It's really extending these construction kits, many different kinds, in a totally different way. That's a really interesting approach. So the possibilities for this are, really far beyond, just pieces for rapid prototyping, but it's kind of a universal connector kit as well for 3D printing.
Yeah, exactly. And, I also get a lot of requests from Fab Labs. Fab Labs, they like to do stuff with kids, and kids are already really great in, putting together Lego. So it's also quite easy for them to use the software as, an approach to get kids into 3D printing. And also they often have the kids over for like half a day or for 6 hours, so there's really not enough time to print a lot, right? Because, it takes some time. So with this approach, kids can basically assemble Lego and have some small parts 3D printed and see how the technology helps them to do new stuff. So that's like one small side thing that actually we enabled that we didn't think of in the beginning.
That's a really interesting point. So I've noticed that in education, there's really limited class time for students to do 3D printing. And what comes up over and over again is that, I want to do 3D printing in my classroom. I've got, usually far more than 10 students. How do we actually print and get something functional within this short amount of time that we have? 3D printing takes a long time. How do we do that? And this is a really excellent way to make that happen for a lot of different classes in the time that they have allotted. So I'm really excited about the possibilities for this. That is fantastic. So how many different people have you been working with? You say you get a lot of requests. Has it been, mostly Fab Labs, or have you been working with schools?
So I get a lot of emails from Fab Labs, but also from schools. So just today I got an email from a Russian school teacher who asked if she can help with Russian translation to make it available for their kids in school, which is great to hear, but it takes like a couple of months more until we are in the stage of translating to different languages. But it's just great to see that basically we get so much feedback from different people all over the world that would love to have it and to prototype.
Well, that sounds great. So we're at the half-hour mark. Do you have anything else that you'd like to share? I don't see any questions popping up, so you must have been very thorough, and that's great. I'm going to check one more time just to see if there's anything else anybody wants to know. Let me look. Nope, I don't see anything. Let me refresh this page one more time. But yeah, it looks like that's it. So if anybody has any additional questions, please post them on the event page, and we'll do our best to answer them later. And this was great. Thank you so much for explaining the process. And I'm really excited about the possibilities of this project and looking forward to the release of the software. So
yeah, great, thanks. And thanks for having us. It was a lot of fun.
Oh, our pleasure. Thank you.
Yeah, thank you. See you.
Bye, guys.